Hello friends, this is Professor Ghanshyam Rathod and now today we are going to see positive series clipper. We're going to see one of the example of positive series clipper. So first of all, let me draw the circuit. I'm drawing the circuit over here. This side is these are the terminals, the branches of the circuit. Now in this one over here that is a load resistance. Here I'll draw the diode. So here is diode. So diode in this direction, and this side is a load resistance RL. Now over here this is a V input and over here V output. So let us see what kind of input is provided. I'm drawing the waveform for the input. Here we'll consider a sinusoidal waveform. This is the time axis. The vertical axis is amplitude. Here I'm just going to draw an input signal, sinusoidal positive half and negative half, one more cycle, positive and a negative half. This side positive, this side negative. V input, this is V max and this is V minimum. V minimum, this is 0. Let me take it, this is t1 time, this is t2 time, likewise it will increase. This is time t for the given axis. Now we will consider for the positive half cycle. For the positive half cycle, here will be positive, here will be negative, and current will move like this way. Okay, but whether the current is going to flow or not, that can be decided by whether the diode is on or off. For this one, if the diode is in on condition, what will happen? Suppose this diode is in on condition, the current will able to flow. And if the current will able to flow, we'll get the V output equal to V input. If the diode is reverse bias or it will turn off, at that time what will happen? The current will not be able to flow from this RL and we'll get that output voltage will be 0. Now we'll check the condition whether diode is on or off for this one. So here is some positive, here is some negative. So we can see that at uh, N terminal some positive supply and P terminal some negative supply. And if we consider a ideal diode, because here nothing silicon, germanium or nothing is given, so we'll consider ideal diode. So to make this ideal diode turn on or forward bias, Vp minus Vn, this should be greater than 0. If this condition fulfilled, at that time we can say that the diode is in forward bias or it is on. Now if you see this one, the diode is right now in this positive half cycle, diode is reverse bias. So that diode condition is reverse bias. So what will happen if the diode is in reverse bias? I can say, I can draw the circuit like this way. If diode is in reverse bias, the circuit is open circuited, like current will not be able to flow in that part. So if I redraw this one, the diode is in reverse bias. So this will be open circuited. So over here the diode is in reverse bias, so it will switch off. So it is reverse bias, diode is off. And what will happen over here? RL, the current flowing through this terminal, the current flowing through RL will be IL will be 0. So V output, if you consider the V output equal to nothing but RL into IL equal to 0. So we can say that the positive part, whenever this terminal is positive, during that time the diode will be in reverse bias and we will get always V output will be 0. So if I draw the output signal aligned with this input signal, you can draw like this way. This is for proper understanding, I'm drawing like this way. So here I'm drawing output signal. So for our case, the output for positive half is nothing but 0. So V output over here it is 0. Now we'll check for the negative cycle. What will happen if I consider the negative cycle? Now let me redraw this one. Over here, when the negative half cycle is there, let us see what is happening. Here will be positive, here will be negative, like the current is moving like this way. So this portion is positive and this one will be negative. So over here this condition is going to fulfill. So in this time, in this way, Vp minus Vn in our case is greater than 0. So now diode is in forward bias. So if the diode is in forward bias, what will happen over here? This will act as an switch is closed. So the switch is closed. Current can able to flow like this way, and these terminals, like as we have drawn above, that will be plus and minus. So when current is able to flow from this one, so IL is having some amount, some value. So we can say IL is not 0. So here we'll get V output equal to nothing but V input. Okay, and over here the V output is going to follow the V input. So in our waveform, what will happen? Whatever input half cycle is there, negative half, that is going to follow at the output. So here we'll get the same output V max negative value. This is V max negative value. So output is going to follow by the input, like input equal to output from this equation we can say. So for this one, the positive part of the circuit is clipped. The positive part, you can say from the output, the positive part of the circuit, positive part of the input waveform is clipped, and negative part is not clipped, it is as it is. It is followed by the input. So here from this diagram you can say this is the positive clippers and the diode is in series with the load resistance. That is why this is a positive series clippers. Okay, so I hope you understood this circuit. For the next circuit, positive, we have seen positive series. Now next one we are going to see positive shunt in the next video. Thank you very much.